So here we go. 277 plus 277. How on earth does that make 480? Let me call up the old screen here. We'll go to the screen. And I'm going to go with my slideshow. Slideshow, play from start. Okay, so this is a Y system. And if you want to know more, you can go back through the feed and look at the delta versus Y and how we have two different systems. We're going to talk about how the Y system here works. So the Y system set up like a Y. And again, if you want to know more, just go back and check out that video. Now, what happens here is I've got three phases. I've got A phase, B phase, and C phase. And the way that this is connected, you notice that A phase has got 277 volts on it, B phase has 277 volts on it, and C phase has 277 volts on it. But when you throw your meter, if you go from A to there, you're going to read 277, but if you go A to B, you're going to read 480. So if you add up, let me just add this up for you, 277 plus 277 equals 554, not 480 volts. Why is that? That is because of this shift here, this 120 degree shift here. You cannot add these guys up arithmetically. I can't just go 277 plus 277 because these guys are heading in different directions. See what I mean here? So we have to add them up is what's called vectorially. And in order to do that, it would take a lot longer than I've got time to go into on this video. But if you go to my YouTube channel, The Electric Academy, I have a whole video on vectors and how those add up. But I'll just give you a quick run through on this. Now, when we add these guys up, it's important that we talk about instantaneous polarity as well. You got this here. Instantaneous polarity is negative. This could be positive, just so you know that I'm just picking one now. Negative here. All these points that go to the star here are negative. Then I have positive, positive, positive. And so what I'm going to do is I'm going to add these up. I'm going to add up positive to negative 277 plus negative to positive 277. But this negative to positive 277 is at 120 degrees. We're going to use this as a reference factor, so we're going to use this as 0 degrees. Cool? I hope you're cool with that because that's the way it's going to roll, yo. Now, just to show, you got 120 degrees out of phase for all of them. So no matter what, if I added this phase to this phase, I'm going to get the same answer as adding this phase to this phase or this phase to this phase because they're all 120 degrees exactly out of phase. All right, here we go. Let me go to the next one here. What I do with my students, I tell them we set up a little XY chart because these vectors here can be split into an X coordinate and a Y coordinate. Now I said that we're going to use this one here as our reference, so I'm going to call that positive 277 on my X and no Y. It's just all X. So if you're having struggles with vectors, give me a private message. I'll send you a link to that YouTube. So I do that. 277 is positive 277, 0 on the Y. Now I'm going to add in this guy here. Now I don't add 277. I have to convert this to an X and a Y. And the way that I do that is I take the cos of 120, I multiply it by negative 277, right? Because we're starting here. That's my reference and up. And that gives me my X. Then I take the sine of 120 and times it by negative 277 to get my Y coordinate. Again, this isn't a trig lesson, so you just have to take my word for it or go watch that video on trig. And that gets me, my X is 138.5 and my Y is negative 239.8. Okay, it still doesn't look anything like 480, does it? Because if I add the X's up, I do that, I'm going to get 415.5. And if I add my Y's up, I get negative 239.8. So at this point, you're thinking I'm smoking crack, except for this is adding these two vectors up and getting me an overall X and an overall Y. So we're going to take this, and we're going to use the power of Pythagoras. Again, you got to watch that trig video, guys, or go to that trig section of my videos. I'm going to go a squared plus b squared gives me the square root of, and that will work out. If you punch it in your calculator, be prepared to be amazed that that is going to be, 480 volts. That's where it comes from. So it's not 277 plus 277. It's 277 plus 277 at an angle of 120. That plays out for them all. If this was 120 and 120, if you did the vector math, you'd get 208. All right, if you did 347 and 347, you'd get 600. Now, instead of doing all this vector math, what they've discovered, or people who are much smarter than even myself have discovered, is instead of doing all this, you can just use root 3. So I could take this 277 and multiply it by root 3, and I get 480 volts. I can take 120 and multiply it by root 3, and I get 208 volts. 347 times root 3 gets me 600 volts. So hopefully you're picking up what I'm putting down on that. All right, I'm going to go back to you guys looking at me for a second here. Let me just call this off here. Escape out of that. I'm going to call up my screen. All right, so there we go. That's just a quick rundown. Hopefully that answers your question as to where the whole 480 volts comes from, or 208 or 600. You've got to add them up vectorially. Because they're out of phase by 120 degrees, you can't just add them up. All right? Hey, I did that in 6 minutes. That's awesome. Again, if you want more, like to go more in detail about this stuff and how all the vectors work, let me know. I'm trying to put together a little 3-phase course, so it'll go into how you can get your voltages as well as get your currents. Now, the voltage in a Y system changes, but the current will stay the same because they're in series. Again, go back to my last video to check that out. But if you go and check out how the current works, your currents are going to be out of phase. Again, I'll get into that some other day. So hopefully, for those of you who asked me, I had 2 people ask me if I could quickly go over that. That answers your questions. Make sure you're sharing this around. If this is helping you guys out, just let me know. Give me a thumbs up on that. I'm loving doing this stuff. Next week, I'm building a presentation right now on, you see that fly flying around the background? It's driving me crazy. I'm doing a presentation on how power gets to your house. So we go through, I'm going to start at the generation station, through the transmission, through the distribution, and into your home. So just a little walkthrough on that as well. Again, I try to keep these things under 10 minutes, just so I know that you guys are on the Facebooks don't have a lot of time to watch these things. So there you go. Pass the word along. Like this page, Electric Academy. Got some cool stuff coming up. Just did a podcast interview with a podcast called Surging Forward. Dave Valentine is an amazing guy. He's got an awesome podcast. So I had the pleasure of doing half a podcast with him. We ran into some technical difficulties. So we're meeting again on Sunday, but it's going to be awesome. He's got some great stuff. So check out surgingforward.com. Also, I'm going to plug my buddy Tim Carson. He's got an awesome podcast as well, the Guild Podcast. Anybody that's into trades, you should be listening to these things. I'm going to leave it at that. I got to go because I got family coming in tonight and don't have a lot of time. So stay safe out there, you guys. There's a lot of cool stuff coming up in the next couple weeks. So be aware. Make sure you join the newsletter. Go to the webpage, www.theelectricacademy.com. And right at the top there, you can sign up for the newsletter. All right. Hope you guys are doing well. Hey, Phil. Hey, Steve. Hey, Zach. And hey, Tim. Good to see you guys. And we'll talk to you later. Stay safe, everybody. And again, keep the requests coming. I'm loving doing this. Send me an email, chad@theelectricacademy.com. Or if you're on Facebook here, which you obviously are because you're watching this, you can send me a message. All right, guys. Have a great weekend. Talk to you later.